Hi, my name is Ranch, and I'm a third-year comp sci student. Currently, I'm working with ECCC, Environmental Climate Change Canada, on the IMWEBs Viewer app. So this is a desktop app which can be installed from GitHub following the instructions. And we also have a web app thanks to University of Guelph providing a Windows server, which works the same way as a desktop app, but with three main differences, which I will be showcasing later down the video. So if anyone has problems of working with the desktop app, you can use the web app. Or if you have problems with the web app, you can use the desktop app. Okay, so this desktop app comes with a test model, which only includes three types of files: .tip files, .shp files, and .db3 files. So even if you select your own folder or your own model folder, then it will only showcase the .db3 files, .shp, or .tif files. Additionally, it also has a lookup table including in this test model. So a lookup table has these abbreviations to full human readable names, which is the user needs to follow a certain format in the lookup database. So in the lookup database, they have to create a table called scenario underscore two, which corresponds with this database that has all the values. So in this database, as you can see, these are human readable names um, according to this table name, table alias, column name, column alias. And it's the same thing with BMP and hydroclimate. So now let's move on to selecting tables. So I will first showcase a simple table. As you can see, you can select it. And you can select multiple tables by adding from different databases as well, as long as they have the same ID column, same date column, and the same interval. These two tables don't have that, as this stations table is missing a time column. And if any type of problem occurs, you can always refresh or close the app and start again. There are a few problems sometimes. So users can select two or more, but currently I'm just going to select two for the demo. As you can see, these two have time and ID, which are identical for them. And if you hover over the columns, you can see precipitations for subbasin snow water balance, and groundwater flow, and ground storage is for subbasin groundwater balance. Finally, we have select IDs, where we will be selecting just two IDs for now, so it's faster to load. As you can see, it loaded for daily intervals, with each ID for all values combined together. And you can even select only one only. Now I will showcase selecting monthly intervals. And when you select monthly intervals, you have to choose at least one of average, sum, minimum, or maximum in method conversion, which will also showcase you statistics of all the final tables selected. So as you can see, we see the statistics for the final table with average, sum, min, max, and maximum time, which is the time at the maximum is at, and minimum time, which is the time when minimum is at. And it's a monthly interval, so it's only year and months. Now we only have yearly interval, which is 2016 to 2022, from the start date to end date. Finally, we have the seasonally intervals. Seasonally are monthly, but with extra column of seasonal and also this updated statistics. Finally, I will showcase how to export things. Finally, I will showcase how to export things. So when you select columns, the export select columns get updated as well. But let's say we don't want a specific column in it, so we unselect it, and the select column is still there. And the same thing with export select ID, we can select like an extra ID to add for exporting, and also for start date and end date. You can update the start date or end date, but if you update the export end date, the selected one won't change. If you update the selected one, the export one will change. And finally, we have export select interval, which can be, and the export interval cannot be less than a select interval. So let's say if we do daily, then and we want export interval to be yearly. And we have two formats, as CSV and text, which are very similar. Um, this is the file name, and this is export path. The default export path exports everything. Also, yes, we should also be selecting average, some minimum, or maximum for export interval, as the interval is greater than daily. Additionally, when exporting, we also have to select if we want only the table or stats as well. This time we want stats, as we're including everything. As you can see, this is default export called data export, and this is our default CSV file without, as you can see, it did not include the air temperature, which was removed, and we have the ID of 4. And it's also yearly date. As you can see, the year is for per year up to 2016 to 2022 with the statistics as well. Now we can select our own model folder. So the user, if the user wants to select their own model and include their own model database or shape files or TIFF files, they just have to click on the file, and it will automatically select the files folder as the main folder. And we can combine these two. So as you can see, both of these from different databases have the same time and ID, so we can combine them. As you can see, we have these values combined together with the value and value from flow and flow inside flow from reach water balance. Now we can move on to the final component of table and project and table, which is calculator. So for a calculator, we have the time and ID, which will not be included in the calculator. We can select precipitation, snow blow, air temperature, irrigation gain, and irrigation loss. Now the calculator, this is the calculator that pops up, and there's the auto mode. I will try every single one that's possible. So if you click a number and you add any of the sign, it will multiply each existing column. It will update the existing column by that number. Or we can have just directly selecting the math operator, plus, minus, addition, or division, and it will create a new column that is named this, that will add all possible columns that were selected in auto mode. So let's try that. As you can see, it used its original column names instead of the alias, which are human readable. As if it was the alias, the column name would take up too much space. And finally, we also have the manual mode, where we can choose specific columns instead of choosing all possible ones. Let's say we just want to add this and and multiply it by 5. So we multiply snow blow in and out by 5. And what now it will be possible to fetch the new column, which was P plus 5 times P blow. This is a calculator. What it did is multiply precipitation, add precipitation plus 5 times 0. It's still 0, so it's just 1.63. Moving on, I will showcase the three differences that I mentioned between a desktop app and a web app. So this is how a web app would look with email and password as well. Additionally, there's also an age captcha. And if you're new to a web app, then you should click Contact Admin and enter your name, email address, and a message asking for a password to try the web app. Or you can just click on the help, and if you're having trouble with the website, then you can use the web app by clicking here and going to instructions uh, and following the instructions here in installation for your platform, Linux, Windows, or Mac OS. So the functionality is still the same, but the select, so that was the first difference. Now the second difference, which is the select folder. So when you select the folder, there's just, you click on the folder that you want to upload, and it will ask you if you want to upload it to the server, meaning your own model will be uploaded to the Windows server at University of Guelph. So now it's done. That's the main part. And if you want to go back to a test model, you can just reload, and you won't need to sign in again for at least for 1 hour. Now I will showcase the third part, uh, which is export. So the export path, it doesn't matter because it's a Windows server and it will just be giving you one zip file containing everything. Or it will just give you a single CSV or text file, depending on how you're exporting in later modules like graph and map. As you can see now, it sent you from the server, it sent you this Microsoft Excel file, which is basically CSV, and it will be saved as a download file, which can be opened by just clicking here. As you can see, these are the values, a lot of them. So that's the third difference. As you previously saw, the third difference was instead of saving the file to a default place locally, uh, it popped up a download folder that where you can save anywhere, as it's a web app and the web app doesn't have permissions to save files locally. But since this is a desktop app, it can be saved locally by even changing the path to something like this, and as you can see, we changed the path to this folder, and it loaded everything in this Excel file. Now, as you can see, we only chose net precipitation. Now we can move on to our graph section. The windows 1, 2, and 3 are very similar to the project and table section. And we can also, but the only difference is x-axis and y-axis. So we choose a table. We can also choose multiple table, but I will choose this one as it has small values and high values to showcase our secondary axis. And usually when the values are a lot, especially for daily intervals, monthly and yearly, there's less values. But when it's daily, you should it's recommended to choose a single ID, as each ID is connected with the column selected. And we finally have graph type, and we have line and bar, bar and scatter, line bar. I'll choose bar and scatter for now. We get the regular pop-up to remind us that all columns should be selected if we want custom graph type. As you can see, CHLA concentration are mostly less than 0, and others are bar. And now we have two export formats, PNG and JPEG, SVG, and PDF are all same. Only Excel and PNG are main difference. Only the overall overall look would be the same for PNG, JPEG, SVG, and PDF, but it's just a different file format. But Excel is totally different. So we'll showcase at PNG first. So this is the overall look with the bar graph and scatter for CHLA concentration. Is just similar to how it looks here. And this is how it would look for JPEG, SVG, and PDF. And now we have graph in Excel, which is basically a graph in Excel with the raw data values. Um, as you can see, it automatically selects the values with scatter and bar according to ID 0 only and date as well. Finally, we can showcase our calculator. And let's say we just want to add all of them together. And finally, we also have bar graph or scatter. I would suggest first we have to fetch it actually, and it will showcase remove all the other values as the formula one is the main one that we really needed, and we have to choose a scatter or a bar. And if we choose it in bar, it will showcase bar. It's our choice. I believe scatter would be a better one. And it's scatter. Now we can also export as Excel. As you can see, we have the new one as bar, as that was chosen before. And only this one is scatter. Um, Finally, we can also try our yearly. This is a yearly for our calculator. And if we want to not use a calculator one, we will have to try reload again. It usually doesn't take long, and as the backend has received the same type of request before, it loads faster than the first time. There we go for all columns and ID 0. And we can also choose and graph our own graph type. A lot of user able customization allowed. Finally, we can move on to our map part, which is the final page of our IMWEBs viewer. And we can also select multiple here. So we will select a shapefile and a TIFF file and wait for it to load, as the TIFF files take longer to load. And now we can fetch it. So as you can see, we have the polygon. If you hover over it, we have the values for these parameter columns that were automatically selected. And if the user wants, they can customize it themselves. We have this legend for the TIFF file, where each value is showcased. For the darker colors, the lower values, and the wider ones are the higher values. Over here, we have the polygon color, the opacity, the line color, opacity for line, and point color and the point opacity. These are default values. The users can play around with it and customize it themselves. And the selected feature statistics, and spatial scale, we will be getting that when we combine a shapefile with actual database table data. Now we will be combining our subbase shapefile with actual data from our database, which is subbase's no water balance. And we can select these four parameters that will be helpful when we are selecting our for calculator, and also for um, the selected feature and spatial scale. So for spatial scale, since we selected the subbasin as .shp, it automatically selected the scale. And if the shapefile is named something else, I will recommend users to manually select its subbasin, subarea field, or reach. And subbasin, subarea field are all polygons. Reach is the only one that's a line. Finally, we have the selected feature, which we can choose from any of them, but I will choose presentation for now. As you can see, it's loaded now, and we have these daily values averaged. They're averaged, as that was the default statistic selected. And we can click on any of these values, and it will load the table for us for that ID. As that ID was 58, it will load all the selected values that we selected, parameters we selected here, and also the graph as well. And as you can see, the air temperature usually goes in negative because that's what it is. Finally, we can try monthly. And we can select our own month, but for now, I will select all possible months. Again, this is about precipitation, and users can select any of these current selected values as their main feature to load the legend and colorize the polygons according to the data in that value. As you can see, this is for monthly, and they're higher than daily, as the monthly values are for each month in a year. And now we have it for each year, for 2016 to 2022. And like I mentioned, you can select any of the other ones. Okay, so we will be exporting this file as a PNG first, and what it will return is a zip file containing a screenshot of this image, and also the selected shapefiles separately as a GeoJSON image as well. So this is our first image, which is the sub-basin one. Uh, this is basically a GeoJSON type of one with a north arrow and different values. And finally, this is just a screenshot of our image here, exact same. Now we are going to export things to shapefile. It will again give a zip file containing all of the exported shapefiles, including uh, the precipitation data, as that is our main data that we're working with. Sorry, precipitation feature, as that's the main feature. And what it does is updates the export file name with the shapefile and the interval, the feature name, finally mean, as we're using average. Now we just have to wait for our zip file containing all the shapefiles to be received. Now we can add these shapefiles to QGIS and see if they match or uh, other the ones that were loaded before. As you can see now, they perfectly match what we're seeing here, except the colors. But if we go to our attribute tables, we can see our precipitate has these yearly values according to the interval, since it's yearly and precipitation and mean. Now we will work with our subarea and subarea nutrient loading, as that is the one that goes with the subarea shapefile. And we will mainly be doing TP runoff. Finally, we'll just do daily. And we will have selected feature as TP runoff. Um, Average and subarea, as it's also named subarea shapefile. This is a subarea highlighted according to the TP runoff with different values. Now we will still be using subarea nutrient loading, but instead of subarea, we'll be using field. So this time, since it also contains the word field inside the shapefile, it automatically selects field, and we will be loading our values for field. As you can see, these values differ very much from subarea, as the polygons are different and the colors are also different as well. Sorry, the colors are similar, as TP runoff is one of has a same scheme, and as you saw previously in precipitation, there was a different scheme. Moving on, we'll be working with reach, which are the only lines, as we've been going over subbasin, subarea, and field. And for reach, we will be using channel sediment balance. And we'll be only using sediment out for now. And as you can see, the selected spatial scale was not selected, as the file name is streams instead of field, or sorry, instead of reach. So we have to manually select reach, indicating that it's reach spatial scale. Like I mentioned, reach is the only one with lines, and these lines are also differently weighted, as the higher ones are like thicker, while the lower ones are thinner. as you can see for the white one and the black one. And this is for sediment out, which is grayscale. Now, to finish off everything, we will be conducting a calculator formula for subbasin. Okay, so we'll be using precipitation, snowblow, air temperature, wind speed. Actually, just that much is fine. And all right, we still have to select our formula. We will go into manual mode and select. Personally, we will add we multiply precipitation by air temperature and divide by snowblow in out. And since some of the values might be zero, from my supervisor, Dr. Louis, he mentioned to reduce it to a 0.001. So we replaced the zero values with 0.001. So instead of dividing by zero, it's dividing by 0.001 for any zero values. If it's not a zero value, then it's going to stay the same. And the selected feature we will not be selecting that, as it automatically selects it according to calculator. We see that the values are really high for precipitation times snow blow in out. Times temperature and divided by P blow, which is snow blow in out. And finally, thank you for watching my demo video. And if you have any help, if you need any help or having trouble, you can always go to help page, which indicates some of the common issues, or the GitHub page where there's also a list of the common issues. As you can see, this is my GitHub page, which has all the code for IMWEBs viewer. It's public, everything. And I'll be putting my demo video right here. It also has the installation for the app, our desktop app, the common issues, and finally acknowledgements for all of the technologies, front-end libraries, Python libraries, and finally special thanks to everyone who's helped with the IMWEBs viewer, their guidance, data, and support.